Hi class, in this lesson we're learning to find the volume of pyramids and cones. In the last lesson we learned about finding the volume of prisms and cylinders, so making that connection. For prisms and cylinders we could think of stacks, like we have this square or this rectangular CD case multiplied by the height of that stack, or a pancake multiplied by the height of the stack of the pancakes. Well, pyramids or cones are different because instead of having the same cross-section throughout, it comes to a point. It comes to a vertex. Okay, so it turns out that there's a relationship from one to the other, though. A rectangular prism volume is the area of that cross-section times the height. For the pyramid, the volume is going to be still that rectangular bottom times the height, but since it comes to a point, it turns out that it's exactly 1/3 of the volume of the other one. So you have to multiply by 1/3 if it comes to a point. Okay, so for a cylinder, our volume is the circle, which is pi r squared, multiplied by the height at which that happens. Well, for a cone, when it comes to a point as it goes, then the volume is the pi r squared h. So making this connection here, what we see is that when it comes to a point, such as in a pyramid or a cone, then we need this extra 1/3 factor compared to a prism or a cylinder. And again, the key idea is that this is a capital B because that's actually the area of the bottom of the pyramid. Okay, so for this first problem, what's the volume of a pyramid with base area of 21 square centimeters and a height of 18? Okay, so finding that volume, it's going to be 1/3. The base area, B, is 21, and the height is 18. So like in this picture, the area of that bottom part is 21, and the height from the center of it straight up to the vertex is 18. So multiplying that together, we'll get 126 cubic centimeters. Cubic because we're in volume. This Great Pyramid in Egypt is the largest of the original 7 wonders of the world. The pyramid originally had dimensions showed below. What's the approximate volume of this Great Pyramid? Okay, so we are assuming that this base is a square, which is 755 by 755. So finding that whole area, we want to square that. That's the common mistake, is to not multiply 755.5 multiplied by itself. So that whole base, when we multiply that together, we'll get 570,780. Okay, so calculating this volume, it's 1/3, since it's a pyramid, multiplied by the base, which is 570,780, multiplied by the height of 485. Okay, so multiplying that together, we'll get 92,276,000 cubic feet. So that's why it's this Great Pyramid, one of the 7 wonders of the world, is because of its size. 755. In this problem, what's the volume of a square pyramid with base edges of 40 and a slant height of 25. So it is 40 by 40 on the bottom. But the problem here is we're not given this height right there. So if we take this right triangle here and just draw it out here, then this distance here is going to be half of the 40. So that's actually 20 on the bottom. We're looking for this height, and the slant height, in other words, this distance up the side of the pyramid, is 25. So now we could go ahead and calculate the height using Pythagorean theorem. So going through that, we'll have 20 squared plus b squared, since h is a leg, is equal to 25, since 25 is the hypotenuse. Okay, so we'll get 400 plus b squared is 625. When you take away 400 to both sides, you'll get b squared is 225. So square rooting both sides, we'll get b equals 15. So that means that the height of this is 15. Okay, so finding this volume, the volume is going to be 1/3 the area of the base, so that's 40 times 40. The common mistake would be to just have 140 in there, but it's 40 times 40 times a height of 15. Okay, so multiplying that together, we'll get 8,000 cubic feet. Okay, so in this problem, what's the volume of a square pyramid with base edges of 24 meters and a slant height of 13 meters? So if we draw this, I'm going to draw this square pyramid. I'm going to put a point out here and connect it to all the vertices. Then its base edges are 24, so it's 24 by 24. And the slant height, so I'll use a different color here. The slant height is this distance on the outside, and that is 13. So we have to calculate what the actual height of the pyramid is right there. Okay, so if you could work through this problem and calculate the volume of this. Here, what's the volume of the square pyramid with base edges 18 and a slant height of 15? Okay, so we're looking for the height here. So there's our right triangle in here. If I draw that right triangle out so I could see it more clearly, then we're going to have half that distance, 9 on the bottom. We're looking for the height, and the slant height, or the distance up the side of the pyramid, is 15. So calculating this, we'll get 9 squared plus b squared is 15 squared. Okay, so 9 times 9 is 81, plus the unknown, the leg squared, is 225. So taking away 81 to both sides, we'll get b squared equals 144. So square rooting both sides, we'll get that the height is 12. Okay, so calculating this volume, it's 1/3 times the area of the base, so that's 18 times 18, times the height that we just calculated, which is 12. So multiplying that together, we get that the volume is 1,296 cubic yards. So for a cone, the volume's the same idea, only the cross-section, that bottom area, is pi r squared. So in this problem, it says, what's the volume of the cone with a base diameter of 14.4 feet and a height of 12 feet? So in this picture, the 14.4 is the diameter all the way across it. So our radius is going to be half of that, which is 7.2. Okay, so calculating the volume, it's going to be 1/3 multiplied by pi from this formula times the radius squared, so times 7.2 squared, multiplied by the height, which they tell us is 12. Okay, so putting that in the calculator, the volume is 651.4 cubic feet. Taking a look at this problem, the tricky part here is that this 11 here is not the height. That's the slant height, or the length along the side of the cone. So in order to find the height, we have to draw in our right triangle right there. Okay, so we're looking for that height right there. So drawing that out, then this length here is half that diameter, so that's 4. We're looking for that height, and the slant height is 11. So using Pythagorean theorem here, we'll have 4 squared plus the unknown squared, h squared, is 11 squared. So going through this calculation, 16 plus h squared is 121. So subtract 16 to both sides. You'll get h squared equals 121 minus 16, so that's 105. And square root both sides. So h is the square root of 105, which is 10.2 approximately. Okay, so based on that, we can find the volume of this drinking cup. Okay, so it's 1/3 multiplied by pi multiplied by the radius. Here 8 is the diameter, so the radius is 4, and that's squared, times the height that we just calculated, which was 10.2. So putting that in the calculator, we'll get 170.9 for our volume. And that's cubic centimeters. For this problem, what's the volume of cone with a base radius of 4 inches and a slant height of 5? So since we have the slant height here, it's really very similar to the last problem we did. So we have to actually calculate the height using Pythagorean theorem and then find the volume of the cone. So go ahead and do this calculation.